China has made an extraordinary achievement by becoming the first foreign country to land and explore Mars. Its lander successfully touched down on the planet after a challenging parachute descent, sparking excitement in the global scientific community. As part of this ambitious mission, evidence of climate change on Mars, which occurred around 400,000 years ago, has been discovered. These new findings have raised many intriguing questions about Mars' geological history and indicate that liquid water once existed on its surface. The Jang mission in the Utopia Planitia region has produced surprising discoveries that challenge previous views about the planet's climate and its potential to support life. Researchers are now working to analyze the fascinating clues provided by Jang, gradually uncovering a clearer understanding of Mars' complex history and evolution, hinting at the possibility of ancient life. In today's video, we will delve into this issue in depth. If you enjoy our video, please click to subscribe so you don't miss our latest updates. Now, let's begin our journey of discovery about Mars, Earth's neighboring planet that has captivated scientists and astronomers for centuries. Questions about water on Mars and the potential for life continue to intrigue us. Extraterrestrial exploration has led to many discoveries, and the latest findings from China's Mars rover provide new and hopeful insights about the red planet. Recent data suggests that Mars may have had liquid water on its surface more recently than scientists previously thought. Research indicates that liquid water existed around 400,000 years ago. This finding is significant because it challenges the long-held belief that Mars has been dry and lifeless for billions of years. It opens new avenues for exploring the planet's geological history and its potential to support life. The search for water on Mars began in the late 1800s when astronomers observed channels and grooves on its surface, leading to theories about past water flow. Since then, many space missions have aimed to gather more information about Mars' surface and climate using advanced spacecraft and spectroscopic tools. These efforts have confirmed the presence of frozen water at the poles and in craters. However, until now, many scientists believed that most of Mars' water had disappeared millions or billions of years ago, leaving only remnants from its ancient past. The discoveries made by the Jang mission add significant value by showing that water existed for a longer period than previously thought, suggesting that Mars had conditions suitable for life. The question remains, how much water is there on Mars, and can it support extraterrestrial life? Future research aims to answer this question. Overall, China's discoveries have transformed our understanding of Mars' history and potential, paving the way for significant future missions to explore the red planet further. In May 2021, China reached a major milestone in its space exploration journey when its rover successfully landed on Mars. The rover began conducting a series of innovative studies in the Utopia Planitia region, located in the northern part of the red planet. Scientists used three main instruments on the rover to collect sand samples from dunes and investigate unique salt cracks in the area. These findings provide strong evidence that liquid briny water exists on Mars and could be much more recent than previously thought. Kim Siwon, a geophysicist at the Chinese Academy of Sciences and the lead author of the study, explained that the surface features of the dunes in Utopia Planitia indicate the presence of liquid briny water. He suspects that this phenomenon occurs due to the melting of ice or snow in the salt-containing dunes, facilitating the formation of liquid briny water. This discovery provides strong evidence of water on Mars. During a much more recent period than previously hypothesized, the dunes in Utopia Planitia exhibit distinctive crescent shapes, indicating erosion processes that have occurred over hundreds of thousands of years. Scientists have also observed several intriguing phenomena in the dark dunes, particularly the formation of cracks at different angles compared to those found in windswept dunes. These cracks, similar to those found in the lower mid-latitudes of Mars, have been studied, but current global atmospheric models do not fully explain how they formed. This study provides new evidence of water on Mars and raises questions about the planet's geological and environmental processes, especially in cold, salt-rich areas. China's rover discovered crescent-shaped dunes on Mars. Orbital observations show these dunes have a bright layer beneath a darker layer. Researchers found 2,260 bright dunes on Mars, estimating that these dunes formed between 2.1 million and 400,000 years ago based on the number of impact craters. This suggests that the dark material in the dunes appeared within the last 400,000 years, coinciding with the beginning and end of one of Mars' largest ice ages. This ice age is related to changes in the planet's axial tilt due to Milankovitch cycles, caused by the gravitational pull of the Sun, Jupiter, and other planets, along with shifts in Mars' orbit. Both Earth and Mars experience Milankovitch cycles, which lead to climate changes. Between 2.1 million and 400,000 years ago, Mars' axial tilt varied from 15 to 35 degrees, significantly affecting its climate and marking the beginning and end of ice ages. Currently, Mars has an axial tilt of about 25 degrees, indicating a stable period following these fluctuations. Mars' ice ages are very different from those on Earth. Instead of freezing temperatures at the poles, Mars experiences warmer temperatures that allow water vapor and dust to shift from the poles to mid-latitudes. This movement causes the formation of thick ice layers during precipitation events. During the last ice age, water and dust from the atmosphere combined to create these ice layers. Some of these ice layers still exist deep beneath Mars' surface, especially below 60 degrees latitude. Currently, Mars is in a geological period called the Amazonian Epoch, which began around 3.55 billion to 1.88 billion years ago. This period has seen fewer meteor impacts and major climate changes, shaping the conditions of Mars as we see it today. 123. Understanding the climate of the Amazonian epoch is crucial for uncovering Mars' volatile geological and atmospheric features. This also helps scientists connect current observations with ancient climate models of Mars, providing new insights into the planet's history. Recent research has shed light on Mars' geological past. The ridges and cracks found in Utopia Planitia, a vast area on Mars, are believed to have formed from melting snow or frost, with estimates suggesting they appeared between 1.4 million and 400,000 years ago. This timeline indicates that there might have been liquid water on Mars when human ancestors like Homo erectus were evolving on Earth. The discovery of traces of liquid water on Mars from around 400,000 years ago opens up new possibilities for ancient life or the development of microbial organisms there. This finding challenges the belief that Mars has been lifeless and inhospitable for billions of years, suggesting that conditions supporting life existed not too long ago. It opens exciting opportunities for further exploration of Mars' potential for life, viewing it not just as a dead planet but as one that may have supported or could still support microbial life. China's Mars rover mission has garnered significant attention, marking a major advancement in China's space exploration efforts. However, in May 2022, the rover had to hibernate to conserve energy during Mars' harsh winter. Unfortunately, the rover has not resumed operations since then due to dust on its solar panels blocking energy intake. This situation is not unique, as NASA's InSight rover faced similar issues in December 2022. Although the rover is currently inactive, the data it previously collected remains highly valuable. This data can be crucial for guiding future missions to Mars, especially in the search for potential microbial life. The Jang mission's research indicates that missions to Mars can yield significant discoveries, even if the rovers face operational challenges. The data collected before the rover went into hibernation remains invaluable for understanding Mars' climate and geological history. Future missions will likely build on these findings, aiming to uncover more about Mars' potential to support life. The possibility that Mars had liquid water relatively recently suggests that the planet's environment may have been more hospitable than previously thought. This opens up new avenues for exploring the potential for ancient microbi.